Good day, everyone, and once again, we're back together. Thank you for joining us on our channel. And of course, if you haven't subscribed, please just make sure you're part of the family. And of course, you can join in our memberships features. In this case, you just click on the join button and you become a member so that you can benefit from our valuable perks. But of course, also you get to support your favorite uncle in my quest to become a content creator full-time, right? Okay, so let's get right into this question as we are continuing with the November 2022 exam, right? So this is on circuits, or in this case, Ohm's law. Right, so they say the circuit diagram below shows 4 resistors connected to a battery with an EMF E with an internal resistor R. The resistance of the ammeter and the connecting wires are negligible, while voltmeters rather have very high resistance, right? So very first question, as notably it is always the case, they ask us to state Ohm's law. Remember, it simply states that the current across a conductor is directly proportional to the potential difference provided that temperature remains constant. All right, so let's get into the gist of the question. Right, now they say to us, switch S is closed, right? So there's our switch S, we can see it there. All right, they say the reading on the ammeter is 3.5, right? They've indicated it to us there with switch S closed. Now, what I'd like to do, ladies and gents, is that I always try to analyze my circuit before I actually even answer the questions, right? So in this case, what do we have? We'll have total current, right outside. In this case, obviously, total current would pass through that ammeter. Now note, in this case, it means that the total current that is across the circuit is 3.5 amperes, right? Now, when we get to this node over here, what begins to happen, right? So now current divides, and I want us to note how it divides. So some of the current goes to the 1 ohm resistor. Okay, so we know we'll have that current. We can actually just give it a name there. Let's call it I1. Okay, and then some of the current obviously will go across that set of resistors there. Now note, it will pass through the 3 ohm resistor as well as the 2 ohm resistor, and at this node both currents come together again, and of course you'll have the total current going out there, and of course going back into the battery. Now it doesn't matter whether you start on the negative side or on the positive side. The rule, the product would still be the same. It would still be the same thing, right? So in this case, what will happen, right? So I want us to please quickly note, because what would be a misconception here, I know many of you would tend to say, well, it means the 1 ohm resistor is in parallel with the 3 ohm resistor. That is not so. Note that these 2 resistors are in series with one another. How do I know that they're in series with each other? Because the same current passes across them, right? So what does that mean? It means it is the combination of these 2 together that is now in parallel with the 1 ohm resistor. I hope that makes sense, ladies and gents. Okay, right. And in this case, we can see that V2 is actually the voltage across both those resistors. And as a result, it's the voltage in the parallel circuit as well as the voltage across that 1 ohm resistor. Right, I like doing that, ladies and gents, because it's important for us to always analyze our circuit, right? So they say to us, calculate the total external resistance of the circuit. Now, I want you to note, we said, in this case, it's these 2 in series. The combination of both of them is in parallel with the 1 ohm. And obviously, all of them combined will now be in series with the 4 ohm resistor. So let's take it one step at a time, right? So let's take our R series. That will be in this case, let's just say R1 plus R2, which will be 3 plus 2, which gives us 5 ohms, right? Now, both of those resistors are in parallel with the 1 ohm resistor. So we can say 1 over R parallel is equal to 1 over R series. Let's call it RS1, okay? So let's call it R series 1 plus, let's just call that one R3, right? So in this case, I get, now remember, if we've got two resistors that are in series, we can always use the product over sum rule, right? If you want to, you can continue with this and say this would be 1 over 5 plus 1 over 1, right? But in this case, I always like to, just make my work very easy. So R parallel would simply be RS1 times R3 divided by RS1 plus R3, right? It will give us 5 times 1 divided by 5 plus 1, which will be 5 over 6 ohms. Right, so that it becomes easier for us to work with, I'm going to leave it in that fraction form, right? So it means that essentially we've taken all of those resistors combined and we've made them into one resistor, and the effective resistance of that will be 5 over 6, right? The effective parallel resistance, that is. Now remember, so what I've essentially done is I've now taken all of those resistors and made them the 5 over 6 ohms, right? And all of them are now in series with that 4 ohm resistor there, right? So as a result, it means that we're going to add all of those resistors to get our effective resistance or our external resistance. So it will be 4 plus 5 over 6, right? So we can say that R external would eventually be equal to that R parallel. Let's call that one R4 in this case. So that would be 5 over 6 plus 4 ohms. And so that will be 4 and 5 over 6 ohms. Right, I don't want to ruin it by, well, at least just trying to take the estimate of this value. Let me rather, in this case, just leave it in that form, right? So they say to us, calculate the reading on V1, right? Now remember, V1 is actually the external resistance of the circuit, right? So what I do know is that V1 actually is the voltage across the terminals of the battery, right? But remember, that is the voltage outside of your V loss, the one in the internal resistance. So it's actually what the battery supplies to the external circuit. So we know the external resistance, but we also know the total current, isn't it? So we can therefore say that V external, okay, will be equal to I total multiplied by R external. So therefore, this will give me 3.5 amperes multiplied by 4 and 6 over 5, right? So we can actually just calculate that. Let's see. So that will be 4 and 6. So that's 4. So I'm actually trying to clear that there. Okay, let's do this. 6 over 5 rather, plus 4. Okay, gives us 5.2, and we get, so that's multiplied by 3.5. So that gives us 18.2 volts. So that's 18.2 volts. And as a result, that is going to be our external voltage. Ladies and gents, I hope that makes sense. I did not label those very clearly, and it's really terrible for me to do so. So that's going to be 8.2.1, okay? And we wanted V1. In fact, V1 is actually V external. So that's 8.2.2, right? And then the last question in that bunch, they say, how does the reading on V2 compare to the reading on V1? Choose smaller than, equal to, or greater than. Now remember, V2 only gives you one, or the parallel combination only, right? Whereas V1 gives you V2 plus the voltage across the 4 ohm resistor. So clearly V2 is going to be smaller than V1, since V1 actually includes V2 in it. I hope that makes sense. So we can just simply say for 8.2.3, that will be greater than. So that's greater than. Okay, actually, they had said compare, or V2, how does V2 compare to the reading on V1? Sorry, that would be smaller than. Apologize for that. So that would be smaller than. Okay. Shoo, my handwriting. Right. Okay, and now we continue to the next part of this question. Right, now they say to us, a learner concludes that the EMF of the battery is equal to the reading on voltmeter V1, right? Well, obviously that's not going to be true, right? Because remember that because we've got an internal resistance, part of the energy that is supplied by the battery, in this case, will be, lost to the internal resistance, right? So they say to us, define the term EMF. Remember that EMF, we say it is the total energy, okay? Or we can say the total work done per unit charge, right? Inside the battery. It is the total energy per unit charge within the terminals of the battery, right? Right. So they say, is the learner's conclusion correct? So obviously we know that for 8.3.2, that's simply going to be no. And they say, give a reason for your answer. And as I actually had said, that, the energy, or rather some energy will be lost. Some of the energy will be lost, or we can say because of the presence of an internal resistor, right? Will be lost to the internal resistor. Okay, right. So in this case, that would not be a correct statement because of that internal resistor. Right, now you can see my battery is almost over. Right, so they say switch S is now removed and replaced by voltmeter V2 as shown in the circuit diagram below, right? Now they say, how will each of the following change? Now, ladies and gents, before I answer this question, when they ask you these type of questions, right, the first thing you ought to always remember is, the change, or rather, once they change something about the circuit, the first thing that you're going to look at is how does that affect the external resistance, right? So that's the first thing that we look at, and as a result, that will actually affect everything else, right? So they say, how will each of the following change? So remember that switch S is now removed and replaced with that voltmeter. So what does that voltmeter do, right? Remember, once we put a voltmeter there, a voltmeter has got infinite resistance. It means it will not allow current to pass through there. So as a result, what that voltmeter does is that it cuts out that 1 ohm resistor, right? So as a result, it means that we are now going to have the total current going from A going through the 3 ohm resistor, the 2 ohm resistor, as well as the 4 ohm resistor, right? So in fact, what would we have done? We have now increased the external resistance. Remember that, and whenever you remove a resistor in parallel, you increase the external resistance, right? So it means that R external would therefore increase. And remember that an increase in R external would decrease the current, right? So they say, how will each of the following change? The power dissipated by the 4 ohm resistor. Now remember, we said R external increases, and therefore what happens? I is V over R. So it means that an increase in R external would now decrease the current, right? But we know that power is equal to I squared R, right? So once I decrease that current, it means that the power dissipated would also decrease. So in this case, it means that we would experience a decrease in power here, right? Now they say to us the reading on voltmeter V1, right? Now, please, I want you to note, ladies and gents, what happens? We've increased R external, the current decreases. What would happen is that V loss, which means the voltage across the internal resistance, right, which is I multiplied by R. So because we have decreased current in this case, it means that V loss would also decrease, okay? Now, we know that EMF is equal to V external, which is V1, plus V loss, right? So because EMF stays constant, it means that once we decrease V loss, right, in order for that value to remain constant, it means V external would have to increase, right? I will explain that again. So I know that the value of V1 will increase, okay? Again, ladies and gents, right, let's explain that clearly. We said, first of all, what was the first thing that we mentioned? We said R external would increase, right? When we remove that when we put that voltmeter, it means that we remove the 1 ohm resistor. So essentially, R external increases, right? We said I is V over R. So once we increase R external, we know the current decreases. But once we decrease the current, in this case, it means that V internal, or you can call it V loss, right, which is I times R, because R remains constant, okay, right? So once we decrease that current, it means that the internal voltage also decreases. Now, because of this relationship, right, the moment we decrease V internal, which is V loss, because EMF stays constant, therefore external voltage would increase. All right, I hope that makes sense, ladies and gents. It is worth the 4 marks, so you must go through the actual explanation of that. Right, ladies and gents, with my battery running almost to empty, I want to say this is it. And by the way, please remember to become a member. Every Thursday we are meeting as members, right, to just discuss questions and answers, to just make sure that I can assist you as much as possible on any of the sections that you need assistance with. Otherwise, from me for now, I'll see you guys next time. Sharp, sharp.